So today I'm going for our next lecture about Google Cloud, and this lecture is basically those who want to become an engineer or those who want to become a cloud architects or a business analyst. They want to learn about GCP. They can go through this one. So let me go through a little bit about data flow, and then I will go for Apache Beam, and after this I will go for data processing challenge, and then various techniques how we achieve in data flow. So let me go first data flow, and then I explain why we need it. So data flow is a fully managed data processing service in Google Cloud. So this is basically service fully managed by GCP that allow you to develop and execute data processing pipelines. It is a cloud-based service for transforming and enriching data into scalable, fault-tolerant manner. So it's a cloud-based service. Data flow use Apache Beam. So Apache Beam is an open source project, so which I'm going to talk after this. Open source unified programming model. Unified means here same code you can use for batch and real time. Batch and streaming processing. This allow you to write data processing pipeline in a language of your choice, such as Java, Python, Go, using set of high-level abstraction provided by Apache Beam. So Dataflow is designed to handle both batch and streaming data processing workload. It automatically scales up and down based on processing need of your data, and also provide built-in support built-in support such as source and sink. So this is just processing engine. We have source, we have target. Target is sink. Source is just source from where you get the data. So it's also about BigQuery, cloud storage, PubSubs, and many more. With Dataflow, you can create complex data processing pipeline with ease and while taking advantage of GCP managed service and reduce operational overhead and ensure high availability and reliability. What is Apache Beam then? How it works? So Apache Beam is open source, unified programming model designed for building batch and streaming data processing pipeline. It provides set of high-level abstraction in this developed processing pipeline language agnostic way. Apache Beam allows you to write data processing pipeline that can execute in different data engines such as Apache Flink, Apache Spark, Google Cloud, others. So these Apache Flink basically used for real-time batch time, Apache Spark also real-time batch, Google Cloud Dataflow also real-time batch. Apache Beam is based on set of core concept enable you to build a scalable fault tolerance data processing pipeline. They're following the core concept of Apache Beam. So these are core components of Apache Beam. So I'm going to talk about the peak collection, transform, pipeline, runner. So basically what I understand is similar to Spark code. So peak collection is immutable. It's in a Spark like RDD, distributed data set that represent collection of data element. It can also collect key value pairs instead of unstructured data or any kind of data. Transform is operation take one or more peak collection input and perform some processing data element as produce one or more output peak collection. So transform just transfer and again, so it's RDD and transform and again put the RDD. If you know the Spark, so Spark is RDD, here we call peak collection. Pipeline is a collection of transform that executed in a specific order produce the final output. So pipeline is like collection of transformation that executed in a specific order in process and finally all be put together. It's called the pipeline. Runner is an executable engine that take the pipeline and execute a specific data processing engine. Apache Beam work by creating pipeline, transforming the process data in scalable and fault-tolerant way. The pipeline is constructed by chaining together transform that operate peak collection. The pipeline is that executed by runner, which take the care of detail of distributed data approach. Apache Beam support wide variety of data source such as Sync, including Apache Kafka, Google Cloud PubSub, Apache Cassandra, Google BigQuery, and many more. This makes it easy to build data processing pipeline that can inject data from different source, process, and output of result on various data source. So this is just an example which I saw. Let me go through the details. What is the data processing? So this is the example which I showed what is Apache Beam and what is data flow. So now I'll go to reverse. Why we need this? So data processing. What is that? Data processing just reading data and transferring, extract, transfer, load, and create output. This is data transfer. Just input, then process, and the output. The challenge is streaming and batch data. So the challenge is until recently, separate pipeline required for batch and real. So if you have separate pipeline, there is some changes in happen in one, you need to change in another, and also there are a lot of headaches which you need to take care. Difficult to compare recent and historical data. One pipeline are fast, another is accurate. So this is batch, this is real time data processing batch, this is the streaming and serving list layer. Why both? Because we need credit card monitoring, compare the streaming transaction to the historical based data to detect a fraud. So data process challenge. So using this one, challenge is complex element process element, single data input, one at a time element inject from a single source, easy. Combining element aggregation in the hard. So if you have one pipeline, it's easy, right? If you have multiple pipeline, it's very difficult to do. Processing data in different source, streaming and out order and composite reality hard. The solution is to overcome this problem. Solution, they have Apache Beam plus cloud data flow, cloud data flow. This will solve problem. One pipeline batch in real time. Beam plus cloud data flow. Cloud data flow overview. So we are going for the next part. And what cloud data flow, what is do? Auto scaling, no ops, stream and batch processing, build on Apache Beam. Documentation is very, very good. Refer Apache Beam side. Configuration is 100% code base. Integrate with other tools such as a GCP and external. Natively pops up BigQuery Cloud and this one. Connector, Bigtable, Apache Kafka, pipeline are regional based. So big picture of data transform. So if you see here, pops up cloud data store, Apache Avro, Kafka, then stream and batch and cloud data flow. So it's working for both. And then output for analyzing, we use Bigtable, machine learning, BigQuery, and the third-party tool, Big Data Studio, Data Warehouse. This we call, and this is used for machine learning, predictive analysis, caching and service. We use Bigtable. So also next pros IAM. This is for management level. I mean access control. Project level only. All pipeline is project level. Pipeline data access separate from pipeline access. Data flow, admin, data flow developer, data flow viewer, data flow workload. So these are the role. And data procs, and we are working on data flows. Is the less overhead, unified batch for streaming, processing, pipeline info, portability across the data flow, Spark and Flink runtime. Data procs, yes, we are not going to talk, but we can think about this one. Familiar with tools, packages, employee skill sets, existing pipelines. This is we will talk. This part is different, but this is how. And then our next part is data flow versus data procs decision tree. So do you have a dependency on a specific tool, package, or in Apache Hadoop or a Spark ecosystem? If yes, then we use data proc. If no, then we use data flow. So do you have every hands-on DevOps approach, operation, or hands-off serverless one? DevOps, then again we will go. If serverless, we'll go to cloud data flow. And the concept, so basically, if you talk about the Google Cloud exam, so data flow is very code heavy. So exam does not go through deep into coding questions. Some of key concept and terminology will be tested. Elements, single entry of data, easy table and row. P collection is distributed data set and data input and output. Transform is a data processing operation step pipeline use. So Pardo type of transform applied individual element or filter out extract element from large data set. This is the input transform. This is called P collection, and then again transform the P collection transform output. So P collection and Pardo in the example of Java code, one step in multi-step transform process. So this is the process which we apply. This is Pardo. This is PubSubs. So this is Java code which you can pause video and see. Dealing with late out, and so if you processing real-time data, there is a way to sometime you get the data classic batch. Yeah, you get the data from 12 to 12 and then you process. Window based, there is a certain window which you process, this window, this window, this window. Streaming is harding, this here to here, here to here. Streaming accumulation, so keep on accumulating. So let's talk about this. Latency is to be expected, network latency, processing time, and etc. It can be happening dealing with the late. So we need to deal with the late output. PubSub does not care about late data that resolved in Dataflow. Resolve with window, watermarks, and trigger. Window means logically divided element group by time span. Watermark is timestamp. Event time when data was generated. Processing time when data is processed anywhere in the processing time. Can use PubSub provided watermark and source generated. Trigger date time when the result is window element is submitted complete. Allow late arriving data. Allow the time of window re-triggering previously submitted result. Timestamp element count company. So this is basically like if your data will come late and how do you process. So there is a way you can process those data also. There is certain condition in real time or you can ignore. So based on your use case. Google provided template, simple words. Writing the code, Google cloud storage. Then this is the text file you're reading. Cloud data flow, read line, extract and count per word, and output in cloud storage. So you're reading data from cloud storage and putting data in cloud storage. This is used for batch processing. Similarly, we take San Diego traffic data, injects through the PubSub, process data flow, analyze, result in BigQuery. First enable. So the real-time data is coming here. Then we put into PubSub a messaging queue. Then we subscribe and we do some calculation. And then we use for BigQuery. Transform data and calculate average speed output to the BigQuery. Quick command line setup. There is some setup. This one you need to do. Create BigQuery datasets. So BZ mk make directory hyphen data sets and project. So this is the basically some code, and you can pause and use this command and test. I'm not going through into deep. Additional best practices are handling pipeline errors, and there is many way. So bad data you can put cloud subs, and good data you can put here. So there is some way to do. Know your window. Global fix and sliding window. Global is a default user. Single window is the entire pipeline. Fixed time every 5 seconds, 10 seconds. So you have batch size, sliding window, overlapping of window session within certain time, certain element. For example, time last user and spouse. So thank you for watching. Please like and subscribe my channel so I can create available videos.